Good morning. Hi, everybody. I'm Mark Spevick. I've come today to talk to you about learning to learn Houdini. Not so much eye candy for this one, I'm afraid. There's a bit of eye candy at the end. It's mostly about how to approach learning Houdini. Who here has never used Houdini before? Quick show of hands. Who's opened it up and used it a little bit? And who would consider themselves a more advanced user? A few. So we've got sort of mid-users, a few entry levels and a couple of advanced, which is good. This lecture is mostly aimed at sort of the new people to Houdini and people wanting to learn more. Right? It's about learning to learn Houdini. So it's more about sort of the learning theories. So who am I? Who am I talking to you about learning for? Ooh, hang on a sec. So I worked 10 years myself in production on a few great movies, quite a long time ago, because the next 10 years I've been working as head of 3D and course leader at Escape Studios. Which is sort of one of the leading visual effects academies in the world. And we've been creating sort of very good talent directly for industry for sort of the last 16 years, and mostly through our professional short courses. Recently, Pearson PLC teamed up with us. We formed Pearson College London, a new university which is offering undergraduate and postgraduate degrees in visual effects, computer animation, and game design, game art. And we've got a lovely new campus in Soho. So I've spent equal measures in production and in teaching. I'm also the co-chair of the London section of the Visual Effects Society. They're an honorary society dedicated to the advancements of the art and science of visual effects. And my job there is mostly promoting the next generation of artists and helping people move through their careers. So it's quite interesting, all that comes together. So that's who I am. And kind of I know a little bit possibly about education. Whoa. So I'm not used to doing this on the Mac. Hang on one sec. So today I'm talking about learning Houdini and trying to sort of give people an idea and a plan for that. Houdini is no more difficult to learn than any other software, basically. It does work fundamentally different, as I think you heard in the last lecture. It's a very different way of working, and that causes some stresses, which we'll talk about shortly. But understanding this will go a long way to helping you speed up learning it. I mean, yeah, from my experience, it's changed a lot in 15 years. When I first started using it, it was quite a tricky software. But then in version 9, the shelf came out, and it made it a lot more accessible. And there's been a lot more documentations and people explaining sort of the paradigm of Houdini. Once you get that, it does actually become a lot more simpler. And one way you can sort of break down your understanding of Houdini or learning to learn Houdini is to understand where you are. You know, where is my knowledge? Am I junior? Am I a new user, a middle user, or an advanced user? You know, understanding your own limitations can help you plan where to learn. So the way I see it, there's sort of 3 tiers of understanding in Houdini. I mean, these might be fairly obvious, but it's good to sort of appreciate where they are. First is obviously the entry level. These are people that are new and fresh to Houdini. We have the shelf tool makes this easy. You can pretty much, anyone can go in there, add a sphere these days, add some effects, press play, see a result. You know, it's very, very quick and accessible to get in there. The next level, obviously, is the mid-level artists. These are people that have a bit of experience in Houdini, slightly better understanding of what's going on. You know, you're able to understand more the intricacies of what the nodes do, change some of the parameters to change what the shelf does and to get more of a custom effect you want. You may even go in there and add a couple of nodes to change that behavior. And then we have the power user or the high-level user. These are people that just go in there and make their own networks or come up with new things or write new scripts or come up with new techniques. You know, the place I think where most people would like to get with their Houdini journey. So how do you get there? Well, you've got to sort of work out a plan. I think we all know how we'd get there. We all say, oh, we're going to watch a few tutorials, we'll try a little bit, and that's it really, isn't it? And it helps to be a little bit more planned, especially with your learning. Coming from an education point of view, in order to write a course, you've got to structure this stuff and break it down, and that's a great process in itself for everybody to do, whether you're going to teach the course or whether you're going to teach yourself. Ultimately, you're teaching. It doesn't matter if you're teaching someone or yourself, right? So understanding those theories can help everybody. So we can basically break down the learning process into several steps. First one is obviously gathering knowledge. You've decided you want to learn something, so what is it you want to learn? You go and find out some information. You might discover some facts, you might discover some principles. As you're gathering that knowledge, as you see, you'll get some concepts, and you'll go, oh, hang on a sec, that makes some sense. Now what I've read makes some more sense because I've just discovered a concept, right? And we have those kind of epiphany moments. And then you try and apply it. You know, you've got your tutorial, you've got an idea, you try and apply it and see where you go from there. When you're applying it, it's actually the interesting stage because that gains you some experience, and through that you find some more problems, and through that you discover some more knowledge, and through that you maybe come up with some new concepts and discover some new concepts. and you find yourself reapplying that again. And this is a repeat and rinse process, which can be summed up in a nice little diagram. So we can learn our key information. This takes us into learning and discovering these major concepts. We can then apply those concepts, which enables us to then discover new information, new concepts, which then drives more information, and we keep going around this circle as we become much better advanced users. You know, it's the application that's important. Take out any of those and this whole system fails. You stop learning. You know, and we really believe this. There's quite a few I didn't go in to start quoting all the educational theories of what this stuff is based upon. But it is, you know, it's a way we kind of design courses. So knowledge, what is that knowledge section? Well, knowledge is knowledge of what? You know, it's just, first of all, you've got to work out what it is. But it's pretty much dry facts. I have a lot of students, I'm afraid to say, that will go there and they'll sit in the lectures, watch millions of videos, but they won't do much about it. And they can say, oh yeah, it's a bump map and all of this, but they couldn't explain to you what a bump map is. They can't necessarily apply it because they've never really done it. You know, but they have this wonderful knowledge, you know, of which there's plenty out there. It's everywhere. You know, can look on Google, you can get your answers from there, and you can learn facts and spout them out and seem like you know what you're talking about. But it comes to applying it and really explaining it to someone else is the real test of whether you actually understand that knowledge. Having knowledge and understanding that knowledge are two very different things. And I think that's where the confusion comes, particularly to a lot of the students that I've seen. They think, you know, watching the video is enough. They don't realize they have to actually do it and, you know, discover that that's the process it's doing. It's very difficult to formulate your deeper understanding of the interrelationships between that knowledge unless you do it, unless you see those concepts, because they're just disparate facts. You don't really know what to do with them. You can quote them, but you don't know how they fit together in the bigger picture. Next, we come to the most interesting bit for me personally, and it's what we call concepts, or in this case, threshold concepts. Concepts are the bigger ideas, not just facts. They're how the facts work. You know, it's the bigger understanding. A good example, if I can relate to Houdini for a minute, would be, for example, the glue. You know, the knowledge is the glue. We can apply the glue shelf tool, we create some glue, we hit something, it breaks it, job done. I know how glue works. And a lot of students say, yeah, I can do destruction, I know the glue shelf tool. But then the concept is not really that. The few concepts or threshold concepts that would help you with that is things like in Houdini, we know that attributes on geometry can affect parameters on nodes and control stuff. We also know that it's not just a glue network, it's actually just a constraint network made of primitives. And applying that with the idea of attributes, you can actually put attributes on your constraint network with different things and get a huge level of control over a constraint network. So understanding these high-level concepts allow you, with your knowledge of the constraint network, to put that together and start to have a much deeper level of understanding on how you might apply those constraint networks in the future. So threshold concepts are very important to kind of identify and pull stuff together. They're quite transformative. You know, they have particular features. They're quite transformative. Once understood, they help you make sense of the knowledge that you've got. They'll change your perspective. You'll suddenly go, oh, I get how that works. I'm sure we've all had that moment. The real danger of that is it's irreversible. Once you've seen that, it's very hard to unlearn it. You know, the danger is you teach the wrong threshold concept, people get a misunderstanding of what you've done. But they're really good. Your perspective has changed. You know, if you see it in a different way, that's the way you'll start to use things. And you know, as a teacher, I'm trying to get my students always to see these threshold concepts in context, so they do have that, oh, I get it moment, and then they are changed forever. They're seeing it in a much better way. They're quite integrative, if I can even pronounce that. They make things obvious between other bits of knowledge. Like I mentioned, with the attributes and the constraint network, suddenly you could connect those and realize, oh, I can do some cool stuff with that. You know, this is the integrative stuff. You're pulling these disparate facts together, and suddenly with your threshold concepts, they make sense. You know, they're like the connections. The threshold concepts are like your nodes, I think, and the knowledge is the connections between them. You start to see all that interconnection of that web of knowledge, if you like. And I think these threshold concepts are great for formulating an efficient roadmap for learning. You know, and this is what I do when I base my courses. I think, well, you know, these are the main principles of Houdini. Once a user kind of understands those concepts based on a lot of other knowledge which they can research themselves, they'll sort of get it. You know, they'll understand how it works or how to get the most out of it. So I think for anybody, they're important things to understand, these threshold concepts. And the most important thing is they are troublesome. They're troublesome because if you get them wrong, you learn the wrong thing. But more importantly, they're painful. I've taught a lot of people coming from Maya, and I've taught a lot of people that have never used 3D before, Houdini, particularly Houdini. And what's interesting is the people that never used 3D before tend to pick up Houdini quicker because they don't have the preconceptions or the concepts of Maya. And that's a real hard sticking point to think about 3D in a different way to something like Maya or traditional 3D, because Houdini certainly isn't that. And I think this is where the people have always said, oh, it's hard to learn. No, it's not hard to learn. It's painful to learn because you've got to think very differently. And that is, you can't really get that offline. It's a very difficult thing to think. But as a teacher, that's the one thing you address straight away is, why is it different? As soon as they get that within a day, actually teaching it makes sense and they pick it up really quick. But it's that initial, ooh, it's so different, that really, really scares people. So yeah, threshold concepts are troublesome as you change your way of thinking to a new way of thinking. You know, it is a painful process and frustrating. But that being said, it's fun. But the most important thing, as I said before, is the application. Without doing, you're not going to learn. You know, we can talk theories of riding a bike. Looks easy. Until you get on it, you don't realize how hard it is, and you realize you've got to do a lot to get good. And it's the same with anything. So when you're applying, you're taking that knowledge, those threshold concepts, and you're seeing if they work. And if they don't work, you learn something new. And that's new knowledge and a new understanding, which you can then reapply to see if you're right. And as we saw before, that's a circular thing, and eventually you become fine-tuned as you apply, discover something new, reassess your understanding, apply it again, and so on and so forth. Summed up in a very nice little diagram. So there's our three sort of facets of learning: threshold, knowledge, and application. And you can see without all three of them, for example, with knowledge and threshold concepts, you've got a great theoretical understanding of everything, but you can't really apply it. You don't really understand the intricacies of trying to do it. But you can talk the theory, you can, you know, explain it to people and stuff. But, you know, the doing is important. Likewise, if you've got the threshold concepts and application, you know, you understand a bit of the sort of the main ideas. You don't really have the depth of knowledge. So when you apply it, you kind of don't always get there, or may not get to the end where you want to go. It's a difficult process in applying it. Again, you haven't got that rounded all three of them. And then knowledge and application is just, you know, I just know what I'm doing. I'm just applying it. I'm not really thinking. I'm not thinking of the overall concepts and stuff. It's a mechanical application. And where we all want to go, going around that circle, is obviously towards the middle there, where we have a good idea of the concepts, a broad knowledge, and we're able to apply it in a very good way. And this is where you start to hopefully get emergent and critical understanding. You start to become creative. You start thinking on different levels, and things become intuitive. You know, you can work yourself out of problems. Enough of the learning theory. Let's try and apply it a bit to Houdini. Again, I'm going on my experience of teaching Houdini over sort of the last 5 and 6 years to all sorts of different people. And for me, the main threshold concepts, or the main ideas of Houdini, are these things here. Is the first one majorly is the proceduralism. You know, that's particularly why it's different to Maya and other 3D softwares. That's the one people need to get their head around first. Once they get that, it's really quite simple. The other things for me personally is you know, Houdini is a file system. It's accessing the data. How do we move data and attributes and other stuff around the network easily? Which is the next bit, how the data flows. Also, what Houdini actually does, essentially all it does is change a bunch of attributes on points, and everything in the interface essentially does that. You know, and once we boil it down to that, and people start looking what's important, I think they get a bit better understanding. Also, conditional statements. You know, a lot of our people I've taught Houdini don't really have a technical background. They've never done coding, so they don't know what a conditional statement is. A conditional statement, for those that don't know, is just something if it's equal, if something is larger than. You're just comparing it, and that will return a true or a false, and that can be used a lot in Houdini in loops of code, or even just in other nodes to turn them on and off. But kind of understanding that from an artist's point of view is a huge revelation if you've never done coding before, and that kind of breaks people into coding, because coding can be scary to people that have never done it before. But again, it's one of those things that it's not, you know, it's just a very different way of thinking, and it's a threshold concept. Once you get over that, which it's easy. And then we've got Vex and Vops. The whole these are sort of Houdini's scripting language is Vex, and Vops is sort of a graphic user interface to interact with that. So if you don't want to script, you can do things through nodes. And again, this is another high-level understanding of Houdini. These can all be broken down again into their own threshold concepts, and I think you can all appreciate it's kind of a big tree of learning. One point as a teacher is to try to break that down into easy parts that build back up. But I'm trying to give you guys a taste that in your own learning, you can kind of look at yourselves and work out your own trees of learning, or which concepts you need to jump to next to get that bigger picture. So let's talk about a couple of those in a bit of detail, or not too much detail because we're a bit pressed for time. But so procedural software, we've seen a lot. Nuke is procedural, Substance is procedural, Houdini obviously. Procedural software's been around a long time, as in Houdini's been around a long time. But also I used to use one called Chalice a long time ago. That was also procedural. So what is this procedural business? What does it actually mean? Well, Yeah. Proceduralism, well, it's a series of well-structured procedures consisting of statements and functions and commands to complete a computational task. Basically, they're stepping stones. A procedure is just something you're going to do. I'm going to walk out that door, that's a procedure. I'm going to sit down, right? Each step, that's a procedure, and each step, you can put them in order to build a journey, essentially. So these procedures are typically like Houdini's nodes. You know, they all describe something. Again, I'm going to compare it to Maya, because most of the people I've taught would have learnt or tend to come from Maya. So in the procedure, we'll talk about Houdini first. It is literally a description of what you're going to do. Each node is only describing what you're going to do. And something like Maya, you do actually do it to the geometry. You load the geometry and you move some points. You overwrite the old position of the points, and that's your new geometry, and it's saved in the scene. In Houdini, you don't do that. In Houdini, you have a node that says, when I process that, I will move the points. So I'm not actually moving them now. You know, like in Nuke, it's just a description. If you open up the scene file, it's just text. There is no data there. You know, we load in the data at some point, and then we spit it out when we process. But actually, there is no data in Houdini. It's just a description. You know, whereas Maya isn't. A great analogy that I like to think of it, traditional 3D software is like sculpting in clay. Oh, I've made something lovely out of clay. I've got to make a change. I've got to remold it, right? And you're doing it from the ground up. You're making irreversible changes to that piece of clay. There's your final product. Houdini's not like that. Houdini's like building a machine. You build a machine to make a pot. And then, when you press the button, out spits a pot. Someone wants to change something, you change the description of the pot, press another button, out comes another pot. And that's Houdini. Houdini's more like the machine that makes the pots. And it's infinitely more powerful in that way, because you're describing what you're going to do. As a result, you can change the instructions anytime you like and spit out something new. Whereas if you're resculpting that pot, you've got to start again, right? And that's pretty much the advantages between Houdini and something like Maya. So knowing it's a description, there is nothing stored in the scene. It's completely non-destructive, because we're not doing anything until we press that magic machine button, right? And you can reorder the instruction set very easily. It's very flexible in that particular way. And I think that's the main sort of understanding of what the difference between selling procedure and something that isn't is. Procedure was kind of like the machine, an instruction set, a set of procedures we're going to do at some point, whereas not is sculpting and the limitations with that. So these little mini procedures, well, Houdini's made of nodes. You can think of those as the mini procedures, essentially, as their own complete little mini computer programs. Each node just does its thing, doesn't care what it does. It brings in some data from the attributes. As you'll see, they're wired together. It'll either create that or read data from another node. It'll do its little thing on that data, and ultimately it just updates the data. It updates is attributes on points. And that's all we have in Houdini. And then those new points go to the next node, who will then do its business on those attributes and then update them, and that's it, it's done. And then the next one. And they don't know about each other. They're completely interconnected, unless they have dependencies, which means you've linked them with some code. Other than that, they're completely self-sufficient. And there's no data stored in them, only when we call it cooking, when they're actually processed. That's slightly not true, actually. When you're in the interface, they are cached up to obviously save time. It's no good if you keep processing a node. One important thing to remember is that if you think about it, if each one processes and sends the result to the next, the one below is always dependent on the one above, right? So if you make a change on one node, everything below needs to be updated, because they were all looking at the data that this node above had. Does that make sense? So anything above doesn't need to change. Understanding, well, let's talk about that on the next slide, actually. So cooking nodes in order, understanding how the nodes are processed is very, very important, again, to sort of get some of those intricacies of the way Houdini works. Here's a little diagram, very quickly, of a very simple network. You'll notice there's a blue eye. This is the node that we want to see. And this often gets a lot of people that start in Houdini, which node they want to evaluate, and they forget to put the right one on. Oh, you've got to turn it on. So that's the one we want to see, and as a result, it's only processing the data that's come into it. So it'll ignore everything below. The only thing that's important was what was above. So if we go up the network, we have, oh, there we go, this node here, then this node, and then Houdini always goes up the left. It's always left to right. So whenever there's a branch, you go up the left-hand branch of the tree, and if it branches again, up the left again. And when you come down, if you've got a branch, you go up the next one to the left, and so on, always left to right. So in that case, we'll go up from the branch here, oh, I lost my cursor again, to this facet, and then up, and this is actually the first node we'll start on the box. And it will describe this box, past these new points that the box has created to transform, which will put those in a new position. This will calculate normals for that. We come to a branch, so we'll go up this left-hand one all the way to the top and start with the grid, where it grabs a point, and then it will copy a box to the point. Then we'll come down here, and then we'll display the result of that. And it will keep going through this kind of process very quickly. The other great concept, interesting concept, is how do we access data? When we write scripts and stuff or expressions, we want to pull data from one node to another or from one attribute to another. So how do we refer to that? Well, Houdini is basically like Windows or Unix. It's a file system. If you look in the tree view, it really does tell you that. You can see we've got root and then our context and then root and then more, a slash and more nodes, etc., and things like that. A great example is the channel expression. As you can see, I've written a little one at the bottom there. It's a file path like Windows or Linux, you know, slash da 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 da. So each node's essentially your folders, and inside those nodes are other nodes, which are other folders. Yep. Yep, so you can access that data that way. Houdini has multiple contexts. Again, the language of Houdini is a tricky one to learn. Things like SOPs, JOPs, CHOPs, POPs, VOPs, these are the contexts. And more recently, MAT, which kind of breaks the convention. I don't know why. Always adds a laugh when I tell that one to the students. And the other interesting thing, so I've been told I've got 2 minutes left, so I'm going to zip through a little bit of it, a bit more. Mostly you'll do your work in SOPs. 9 times out of 10 when you use Houdini, although you can use it for pretty much everything. I've seen people use it for VJ and all sorts of wonderful things, or medical visualization, but most of the time you'll be working with geometry and lighting and rendering. So you'll spend most of the time in the SOP context, the surface operators. And again, if you're learning it from the forums, you've got to kind of learn the language, because you know, you've got to do it in SOPs, send it to DOPs, do it in VOPs, send it back to SOPs, and you'll be like, what are they talking about? So you know, being a bit familiar with the naming context helps itself. And there's this one context that rules them all, the VEX, the scripting language. That actually runs in all of them. And you have nodes that allow you to do this kind of more advanced stuff in every context, in dynamics and particles, the lot. So how do we learn more? Well, what you need to do, first of all, is decide which level of understanding you are, and be honest with yourself. You haven't got to impress anyone, and if you do, you'll learn slower. So just be honest at what level you are, mid, you know, junior, mid, or I won't say junior, that's bad, entry, mid, or advanced. Identify the gaps that you have. You know, be honest with yourself. What don't you know? Write it down. You know, ask on the forums, how do I learn this? You know, search for it, find out more. As you do that, you'll discover there are some major concepts which you can get into or ask questions about. And then you can start to structure a learning plan on how you might want to go and learn that thing that you don't know, right? And then apply. You know, once you've discovered stuff online, try and apply it. Set yourself not too ambitious project, because I find students set themselves crazy projects, don't complete them, and they give up, and that's it. They take they wind out their own sails. So if you do anything, don't be too ambitious. Push yourself a little bit, learn a bit off it, and then try it again, being that bit more ambitious again. And slowly go around that circle, slowly building up. If you do it too big, you'll break it, because you'll kill your confidence. So ways of learning, very briefly. There's a couple of ways that I see it, is online resources. We've got Google tutorials, YouTube, forums like Oddforce and Side Effect. You know, there's a great amount of information resources out there. Quickly, the pros of those is it's free. That's the biggest bonus. You can do it in your own time, and there's huge amounts available to you. The big downside of that is it's not structured. Particularly if you're new to it, you don't know what's good and what's bad. There's no quality control. You could be watching Joe Blogs off YouTube, and he could be telling you rubbish, and you don't know that. And that could be formulating threshold concepts, which you'll get in a skewed understanding of the real thing. So it can be dangerous without experience. It's difficult for new users to filter with that lack of experience, and it could be really, really slow with lots of trial and error. And I find a lot of my students that come to us have tried it on their own, and you know, they found it slow and difficult, which is why we come to sort of structured learning paths. Schools or online courses or physical, schools which do have online courses or physical classrooms. The pros of those is it's structured and guided learning. Hopefully you've got a professional that's thought about this. They've got you a plan of threshold concepts that map together to give you a bigger picture. You know, you have a tutor or a mentor that you can ask, which is invaluable. Your information, hopefully, is quality information. It's the right stuff, and it's fast and efficient because you have a roadmap already set out for you. And often that can be tailored. You can speak to the tutor, and they can monitor your progress through it. The cons of that, obviously, is the cost. You know, it can be expensive, but there's funding options. Also, time and place commitments, depending on the type of online or classroom course. You have to be somewhere for certain periods or whatever else. So there's limitations to that, but the advantages are obviously the speed, efficiency, and the more structured learning. Very briefly, we've got a minute? Not really. 30 seconds. Well, I spoke to a couple of my students who had actually done the course about 3-4 years ago, and then got jobs doing Houdini off the back of the course, and have still got careers doing it, which is wonderful. I asked them a bunch of questions related about their learning. For example, you know, how did learning Houdini help you? Do you use it in your day job? Basically, they did use it in their day job a lot. They did found that one thing was interesting about going to school to learn Houdini was it gave them the learning path, and it made them understand actually what the industry was about, which guided their learning a lot quicker. They felt they got there a lot faster. The things that epiphany moment for them, one of them was VOPs. As soon as he discovered VOPs, that was it. He was away, he thought in Houdini. The other one thought actually grasping the essential concepts came quite easy to him once he got them. Could you have learnt it yourself? They probably could have, they said there, but they said it was difficult and challenging, lots of trial and error. It was very time-consuming, quite painful process. I'm just going to quickly shorten these down. How would you recommend someone learning? You could do it online tutorials, but they both say if you're lucky enough or can afford it, do a course. It's much more guided, much quicker, but you know, ultimately it's up to individual people. Was it easy to learn? Both said it was a bit scary at first, but actually it was quite easy. You know, again, it's that threshold concept thing. Ooh, this is different, but once they try it, they realise it's not. You know, to be fair, it's quite easy. Did you have a technical background? One guy was a modeler, one guy had some maths background. Neither of them, well, yeah, one guy had a bit of 3D, the other had no 3D, just a bit of maths. But both of them, you know, the guy with the maths found Houdini easy to get into. The guy with the experience of 3D modeling found it easy once he realised it wasn't that tricky. So again, that's the whole coming from somewhere else and seeing that it's different and freaking out for a minute, right? Interestingly. Their advice for starting out, forums are your friends. About getting a job, yeah, forums are your friends. It's a great way to learn and understand. And if you want to get a job in Houdini, interestingly, he said it's not just about doing cool effects, it's showing lots of different ways to control those effects. But then that's just his opinion, I suppose. I don't know. You have to ask a recruiter. So what do you think the main threshold concepts are in Houdini? Yep, VOPs, and particularly its procedural nature. And just got a couple of bits of their eye candy, because I didn't have any eye candy. So we still won't see any eye candy. We'll leave that for the next talk. So thank you, guys. If you want to ask any questions, anything about education, come and grab me afterwards or in the floor in later. I'm happy to answer anything about learning Houdini. So thanks again. Cheers.